Hello viewers, welcome to my channel K Srikanth. Today I am going to discuss about the formation of energy band diagram, which is very helpful in the analysis of EDC subject. So let me explain the formation of energy band diagram. First of all, in order to explain the formation of energy band diagram, first we must know the position of electron in an atom. Where does this electron lies and what is the behavior of this electron, and in order to know the position of electron in an atom, we have to follow the Bohr atomic theory, which is globally accepted in spite of some limitations. So let me explain the Bohr atomic theory in order to find the position of an electron in an atom. Bohr atomic theory. Atom consists of electrons, protons and neutrons. Neutrons exist at the center of the atom and it is called the core of the atom. The combination of protons and neutrons is called the nucleons. Electrons exist outside the nucleus of the atom. Electrons are present outside the nucleus in an orbit, shell or energy level. You can pictorially visualize this matter. Here, this is the nucleus. It consists of neutrons and protons, and the electrons is revolving around the nucleus. Let us go through this trace. The electron is revolving around the nucleus and the electrons. There is a force of attraction between the electrons and the nucleus of the atom because they are having two opposite charges. This force is called as Coulombic force. Sorry, that is not a Coulomb, it is an Coulombic force, and it is given by F is equal to K into Q1 Q2 by R square, where the value of Q is 1 by 4 pi epsilon, and Q1 is the charge of electron 1 and Q2 is the charge of nucleus, and R is the distance between electron and the nucleus. And electropotential energy is given by F is E is equal to F into R, and E is equal to K into Q1 Q2. It is not comma, it is product, sorry for this, by R. According to Bohr atomic theory, sorry, here you can say that if what happens if R is increased to the energy, what happens to the E when R is increased. As the distance from electron to nucleus is increased, the energy electropotential energy of an electron will get decreased. But according to Bohr atomic theory, the energy of an electron in the outermost orbit is greater than the inner orbit. That is, the radius, if you increase the radius, the E value should be increased according to the statement, but it is not happen, and the energy of electron at the higher orbit is greater than the inner orbit. This is contrary to the above statements about two formulae, because energy is indirectly proportional to the distance between the electron and the nucleus. So as the n value increases, the energy of an electron should be increased, but we observe contrary to the statements. Let me explain you two statements which will give clarity. Let us, the first statement is, whenever we are applying a force due to which two bodies which are under the force of attraction moving closer to each other, then the work done is negative. That is, let us consider two magnets. It is an north pole, and similarly it is a south pole. These are under the force of attraction, as these are unliked poles. These are under the force of attraction. Then this, the energy, as there is a force, there must be energy, and this energy is negative, and this is attractive. Attractive force, the energy is negative. Similarly, another statement is, whenever we are applying a force on dissimilar charges so that they will come closer to each other, then the work done is positive work done, or the energy is positive. Let me give you example to that. Above second statement, you can visualize. Now this is north pole, and this is also a north pole. The sorry, the diagram I will draw again. Sorry for this. I will draw the diagram. Consider this as north pole, and similarly this is also north pole. At the poles are likely there is a repulsion force, and if we apply the external force so that they will come closer to each other, when we apply this force, then these two magnets will come closer to each other, then the energy is positive, otherwise the energy is negative. So you can say that, so the inner orbit electrons will have attractive forces of nucleus over the electrons, so it will have negative energy, and this negative energy is more than the outer orbit electrons. This is the reason that why electrons at the outer orbit will have more energy than the inner orbit, as negative means it will, as we move higher orbit, the negativity will become less, so the less negative is having more value in terms of positivity. So the electrons at the inner orbits will have lesser energy than the electron at the outer orbit. This is the reason that Bohr said. Next, the position of electron in an atom. According to quantum mechanics, we have four quantum numbers which describe the state of an atom in an state of electron in an atom orbit. It represents the principal shell of an atom. It takes integer values 1, 2, 3 and so on. Maximum number of electrons in a shell equal to 2n square, and the energy of an electron in an orbit is minus 1312 into z by n whole square. We have many formulas for the energy of an electron in an orbit, where n is the shell number and z is the quantum number. Here you can observe that for n is equal to 1 we have 2 electrons, and n is equal to 2 we have 8 electrons. Now the electron lies in the solid, the solid consists of atoms, and the atom now consists of orbit. And next, in orbit we have subshell. Now electrons lies in the subshell. Here it is the nucleus, and it is the orbit, and it is the orbit, and in the orbit we have subshells, and for subshell n is equal to v1, n is equal to 1 we have s subshell, and n is equal to 2 we have s comma p subshell. For n is equal to n we have n subshells. And next, after the subshell, the electron now lies in orbital. Electron will lie in orbital. Only 2 electrons will exist in one orbital. Here it is an orbit. Here for n is equal to 1, we have s subshell, and in subshell we have one orbital. For L is for number of orbitals we have formula 2l plus 1, 2l plus 1, that is for n is equal to 1 we have L is equal to 0 and number of orbital is 2 into 0 plus 1, that is we have one orbital, and in one orbital similarly for n is equal to 2 we have we have L is equal to 0 and L is equal to 1, so that we have a maximum of 4 orbitals. That is from L is equal to 0 we have one orbital, and L is equal to 1 we have 3 orbitals. Here this is the orbital, and this is the subshell, and this is the orbit. Next, energy state. I will give you a definition of energy state. Let us consider this figure. In this figure, in the orbitals we have energy states. These energy states are divides the orbitals in which the electrons lies. So it differentiates the two electrons. That means you can consider it is a divider of two electrons, and in which the electron lies. So only one electron will exist in one energy state. Here energy state is the imagine this energy state as a line. This is the energy state is a line which divides orbital into two. Then energy state is unique. Only two energy states are available in one orbital. That is, in one orbital we have only two energy states. So the material consists of atoms, and atom consists of orbits, and orbits consist of subcells, and subcells consist of orbitals, and orbitals consist of energy states, and in that energy state we have electron. So the final position of an electron is energy state. Let us consider the example of silicon 1s2, 2s2, 2p6, 3s2, 3p2. In that we have 6 energy states in p shell. In that only 2 states are filled and 4 energy states are vacant in the outer orbit. Consider energy diagram of silicon. Here for n is equal to, here observe the diagram. The distance between 1s2 and 2s2, it is the energy difference, and let us consider this energy difference as E1. If an external energy is given, the lower orbit electron will observe and move to higher orbit if the energy given is equal to or greater than the energy difference of the two orbits. You can visualize this. As you give the energy to the electron at lower orbit, it will observe the energy if its energy is greater than the energy difference between the two orbits, and it will move to higher orbit, and after some time, due to instability, the electron now comes to the ground state. The energy we provide externally is the positive, because we are giving energy in opposite direction to the attractive force. If the EA, that is applied energy, is less than energy gap between the two orbits, then EA is not observed by the electron and EA is transmitted. and this transmitted energy is used for the production of phonon. I will explain you phonon after the formation of energy band. If your applied energy is greater than or equal to energy gap, then the electron will absorb energy and move to a energy level n is equal to 2, and it will come back to n is equal to 1 because to attain stability. In the jump, even equal amount, so that is not even, it is equal amount of energy is released by itself. The released energy is in the form of light or heat. You can distinguish how these terms this terms is related to direct band gap and indirect band gap after the formation of band diagram, and I will explain you about the direct and indirect band gap in the subsequent classes. There is no intermediate energy levels is observed in an isolated atom. So an electron always absorbs and releases fixed amount of energy, that is the energy difference between the two energy levels. The energy required to move electron from n is equal to 2 to n equal to 2 is higher than the energy required to move an electron from n is equal to 2 to n equal to 1. Sorry, the energy required to move an electron from n equal to 1 to n equal to 2 is higher than the energy required to move an electron from n equal to 2 to n equal to 3. This is according to the Bohr's atomic theory, and I explained you with the diagrams. So the electron at the higher orbit is loosely bound because, as I told, as we move away from the nucleus, the attractive force between the electron and the nucleus decreases. So the electron at the higher orbit is very loosely bound, isolated atom. It is the atom in which there is no atom with which is interacting. That is, there is no atom within the range of 5 to 7 angstroms beside the atom. Thus atom we can call it as an isolated atom, and you observe that there is no energy level. Energy level is identified in between the two energy levels. Interatomic distance, it is the distance between nuclei of two atoms. Here electrons of atom A will not affected by the attractive force of nuclei of atom B and vice versa. I will explain the above statement. Let us consider the two atoms A and B. Then the distance between the nucleus of atom A to distance between to atom nucleus of atom B. The distance is known as the interatomic distance. If the distance is greater than 5 angstroms to 7 angstroms, then the electron of atom A will not affected by the attractive force of nuclei of atom B and vice versa. Interacting bodies. If the two atoms have the interatomic distance is 5 angstrom to 7 angstroms, then the atoms are known as the interacting atoms. You can visualize this. Atom A and atom B are closely come to each other, and the distance between the nucleus is in the range of 5 angstroms to 7 angstroms. Then this atom A and atom B are known as interacting atoms. So the outermost energy levels are overlapped. As you can visualize this, the outermost orbit of atom A is overlapped with the outermost orbit of the atom B. So there is a repulsion between the nucleus of one atom with the other, and also the outermost energy level electrons now experiences extra attractive force. that is, I will show it. Sorry for the delay. Here, consider if there is an electron here and electron, outermost electron, it is here. When it is revolves and reaches here, now the electron will affected from the nucleus of atom A, and similarly the attractive force of atom B. Now it has the more attractive force from the two atoms. So the attractive force from parent nuclei and attractive force from the neighboring nuclei. So the outermost electrons get unstabilized. Why it is unstabilized? Because it gets the extra energy. That means attractive force is nothing but it gets extra attractive force. Attractive force is nothing but it will have more negative energy. So it is get unstabilized. So an electron are not in the same position and change their position in order to get stability themselves. So they create a new energy states. Note, a very important note is the overlapping of orbital outermost shell will happen only when the interatomic distance is in between 5 angstroms to 7 angstroms only. That is, the distance between these two nucleus is must be in the range of 5 angstroms to 7 angstroms only. If it is greater than 5 angstroms to 7 angstroms, then the outermost of electrons of atom A will not get affected by the nucleus attractive force of nucleus of atom B. It must be noted. Then the final point is formation of energy band diagram. So let us consider silicon solid which has 5 into 10 to power of 22 atoms per unit volume. I will give diagrammatically. Okay, consider this is as a silicon solid which has divided into many number of small spaces volumes. Let the dimensions is be 1 centimeter, 1 centimeter and 1 centimeter. Per 1 centimeter cube we have 5 into 10 to power of 22 atoms. In this small space we have 5 into 10 to power of, in this small space we have 5 into 10 to power of 22 atoms. That means the atoms are so closely placed and easily get interacted. That is, the outermost electrons will get attracted by the parent nucleus and also the neighbor nucleus and gets unstabilized. You can visualize this how closely the atoms is. Let us in small volume it is one atom and it is one atom. Similarly, sorry for the bad diagram, and the atoms are so closely placed, so the outermost orbit are overlapped as a, let us consider silicon solid in a volume of 1 centimeter cube. We have n number of atoms. I have shown that the number of atoms is nothing but 5 into 10 to the power of 22 atoms. Now the number of electrons in the outermost shell of an silicon solid, as you know that the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. In the outermost shell we have 4 electrons. So the total number of electrons present in the outermost shell of unit volume, this is not the value, unit, this is the unit volume, this is unit volume. For n, but each electron should have one energy state. So we require 4n energy states to occupy 4n electrons. In 3s2 we have 2n energy states, and in 3p2, that is not, in p shell we have 6n energy states. So we have total 8n energy states. Out of 8n energy states, in 3s2 2n energy states are filled by 2n electrons, and in the 3p2 2n electrons are filled in 2n energy states. So we have 4n out of 8n energy states are filled by the 4n electrons. The electrons are unstable because of interaction of the atoms. In art, as you know that this interaction is happened because the atoms are so closely placed, because in 1 centimeter cube we have 5 into 10 to the power of 22 atoms. So these are closely so closely interacted. So the outermost orbitals are merged, and we have the electrons at the outermost orbit will affected by the attractive force of the nucleus of the other atom. So the electrons get unstabilized. So in order to get stabilized, the electrons now created themselves in new energy states. Electrons are unstable, so filled electrons will be, these electrons will themselves create new energy states, and the electrons which are filled in the energy states are will occupy in lower energy level. Upper 4n states are vacant. The combination of energy states are called energy band. I will show you graphically. Here let us consider 1s2, 2s2, 2p6, 3s2, and the 3p2. Here these are the outermost orbits. So the atoms in these orbits are affected by the attractive force of the other atom. So for general solid, we have the 8n energy states is now divided into 4n energy states, which are filled by the 4n electrons. These are the filled, and similarly these are the unfilled energy states. These are the unfilled energy states. This the combination of these energy states is nothing but the energy band. This is a band and this is a band. So upper 4n states are vacant. Here we have these energy states are vacant, and these energy states are filled by 4n electrons. and this has lower energy, that is lower energy states. The combination of these energy states is called the energy band. So energy band is defined as closely spaced discrete energy states. The completely filled energy band is called the valency band, and the unfilled energy band is called as conduction band. I will show that. These filled energy states are represented in this space as valency band, and the unfilled these energy states, unfilled energy states, that is represented by conduction band. And the energy gap, and this means this space, the energy gap. Here the y-axis is energy EV, and this x-axis is distance in angstroms. This is the formation of energy band diagram, and this gap is known as the forbidden energy gap, and this is gap is distinct for distinct materials. So I think you have got clarity. If you have any doubts, please comment me. For more videos, you subscribe me, and thanks for watching. And I am thanking Jay Sharath, who helped me in this presentation.